Hey, so every time you use an AI, you're really only seeing half the story. It's true. Behind every, instant answer, there's this secret hidden life, a super long, difficult education that's totally separate from its day job. And this whole difference between an AI's school life and its work life, it's honestly one of the most important things to understand in tech right now. So let's break it down. I mean, have you ever really thought about that little moment of magic? You talk to your phone and it gets you. Or you search your photos for like beach and boom, there they are. How on earth is it so fast? Well, the secret is that the AI doing that work, it's already a finished product. It's not learning anymore, it's just doing. And that simple fact, it changes absolutely everything.
Right, and that's really the core idea here. It's like an AI lives these two completely different lives. We call them training and inference. The easiest way to think about it is this. It's the difference between an AI going to school and then that same AI getting a job. We're talking two totally separate phases, each with its own set of rules and its own goals.
Okay, so first up, let's talk about the school phase. This is training. And this is where the AI model is basically forged from scratch. And when I say school, don't think of it like a fun semester. No. Think of it more like a decade of nonstop cramming for the hardest exam in the entire universe. It's slow, it's grueling, and man, is it power hungry. So, what is training really? Well, it's pretty much what it sounds like. You teach the model by just showing it a ton of examples. And I don't mean just a few. We're talking about massive, almost unimaginably huge amounts of data. The whole point is to get the model to just sift through all of that stuff and start to pick out the patterns and relationships all by itself. But how does an AI actually learn from all that data? Well, it's this relentless cycle. Check it out. First, the model gets some data. Then it makes a guess, a prediction. After that, it compares its guess to the correct answer and figures out how wrong it was. That's the error. Then, and this is the key part, it slightly adjusts billions, yes, billions of tiny internal knobs, which we call parameters, just to get a little bit closer to the right answer next time. Now, just imagine doing that over and over and over again, millions of times for weeks or even months straight. At the end of the day, training really only has one single goal: accuracy. That's it. It's all about making that error smaller and smaller, one tiny little correction at a time, until the model is as smart as it can possibly get. And as you can imagine, this takes an absolutely astonishing amount of horsepower. That's why it's done on these huge grids of powerful computer chips, or GPUs, all of them linked together and working in concert. All right, so our AI has graduated. School's out. Now it's time for it to get a job. And this brings us to the second phase, inference. And this is the part that you actually interact with, probably every single day. Inference is basically when that fully trained, super smart model is finally put to work in the real world. So you give it one new piece of information. It could be a voice command, a photo you just snapped, a sentence you wanted to finish, and it takes everything it learned during all that training to give you one fast, single answer. And this right here, this is probably the most important difference to get. During inference, the model is not learning anymore at all. All of those billions of parameters, those little knobs that were getting tweaked nonstop during training, they are now completely locked in place. The AI isn't a student anymore. It's an expert, just applying its now frozen knowledge to whatever job you give it. So you see, the goals here are the total opposite of training. It's not about becoming more accurate anymore. It's all about speed and performance. The number one priority is to give you an answer as fast as humanly, or I guess machinely, possible. We're talking milliseconds, and it has to do it while using the least amount of energy and computer power it can. It's so efficient, in fact, that it can often run on just a tiny part of a single GPU. Okay, so let's put these two worlds head to head, because when you see the actual differences side by side, it really drives home just how wildly different they are.
I mean, look at this. The difference is just staggering. Training can take days or even months. Inference, milliseconds. And the memory it needs? Training requires a massive amount of memory for all that data and the constant adjustments. But for inference, it just needs to hold the final, much smaller model. Even the precision is different. For training, you need super high precision for those tiny, tiny adjustments. But for inference, you can often get away with lower precision, which makes things way faster and more efficient. They are truly optimized for completely different jobs.
So you might be thinking, okay, interesting, but why does this actually matter to me?
Well, it matters because everything that happens in that school phase, it permanently sets the rules for the job phase. Every decision made during training has a direct, and I mean lasting, impact on how well the service you use works and even how much it costs.
Yeah, it creates this very direct chain reaction. It goes like this. A company spends more time and uses more data for training. That makes a smarter, but also a much larger AI model. And that bigger model, well, it needs more powerful and, yep, more expensive GPUs to run the inference for you. So to put it simply, a better education for the AI usually means it costs more to run the service that you use.
And the stakes here are just on completely different levels. Think about it. What if there's a small glitch during inference? Well, it probably just affects your one request and it's a temporary thing. No big deal. But what if a mistake is made during the training phase? That's a disaster. The model is now permanently flawed. And the only way to fix it? You have to go all the way back to the beginning and repeat the entire incredibly costly training process all over again. Ouch. So this isn't just a technical detail. This divide between training and inference has massive, real-world consequences. It's literally shaping the future of the entire AI industry. And you know what it really all boils down to? Money. Look at this. The upfront cost to train a big, powerful AI model, we're talking millions, sometimes hundreds of millions of dollars. But the cost to actually run that model for one single user, to do one inference, it's just a tiny fraction of a cent. The difference is just wild. And this financial reality, this huge gap in cost, is so profound that it literally forces hardware companies to build two totally different types of computer chips. On one hand, they design these massive, super power-hungry, very expensive chips just for training. And on the other hand, they design smaller, way more efficient and cheaper chips that are built just for inference. The market itself has basically split right down the middle. Okay, so let's wrap this all up. What are the big takeaways? 1. Training is the slow, super expensive learning phase. 2. Inference is the fast, super efficient answering phase. 3, and this is crucial, the choices made during training permanently affect how the model performs and how much it costs to run. And finally, 4, this whole divide is what shapes the entire AI industry, from the computer chips they design all the way down to the business models they use. And all of this leaves us with a really critical, maybe even a billion-dollar question for the future. Right now, training costs millions. Pretty soon, it could cost billions. So when the price of entry, the cost just to school a new AI, gets that high, who gets to build the next one? Who can even afford to innovate? Who gets to build the AI that's going to shape all of our futures? It's definitely something we all need to think about.